Hello, my name is Ibrahim and I'm here to talk about machine learning algorithms. And before we go further, let's ask ourselves, what is machine learning algorithms? A machine learning algorithm is a set of rules or process used by AI to conduct a task. However, there are two commonly types of machine learning algorithms, namely supervised, unsupervised, and reinforcement machine learning algorithms. So therefore, friends, let's take the supervised machine learning algorithms as a discussion for this exercise. Meanwhile, the supervised machine learning algorithms are subdivided into two, namely regression and classification. And we cannot talk about regression without me mention of simple, multiple, and polynomial regressions. And before further ado, let's go into our Jupyter notebook for practice exercise. Thank you. Welcome back. On this our practical exercise project on machine learning for linear regression in Python for beginners. However, before we continue, I would like us first of all to go through the table content of this practical project exercise. 1. Data set and objective. 2. Data analysis. 3. Present the findings and recommendation. However, our data set and objective of these algorithms is to find relationship between variables of x and y using linear regression in order to predict price continuous values nature in the given dataset below for our machine learning. And we are making use of our dataset download from kegel.com dataset of retail sales dataset. However, we can see the website and the file dataset in CSV format here. Here is the website kegel.com that we use to download our dataset from CSV format, and here is the file itself, the dataset itself. And on the column A we have transaction ID, on the column B we have date, on the column C we have customer ID, on the column D we have gender, on the column E we have age, on the column F we have product category, on the column G we have quantity, on the column H we have price per unit, and on the column I, which is the last column, we have total amount. However, since we have seen the dataset and objective of this practice project exercise, let us dive into the content number 2, which is data analysis is subdivided into the following. Let's go into our Jupyter notebook and see the number 2 content, which is data analysis, with the following. 1. Import required library, cleaning of the dataset, exploratory analysis, descriptive analysis, and model building. So let's go and import our required library in this project. We have to import pandas, import pandas as PD. Then we have to import our seaborn too as well. Import seaborn as SNS. We need to import matplotlib as well too. Import matplotlib matplotlib.pyplot as plt. We have to import our numpy as well too. Import numpy as np. In case, let's import warnings. In case by the time we run our code, we will not have unwanted warnings from the machine. Let's import warnings. Import warnings. Warnings.filters. Warning.filter warnings, bracket close, ignore. So for now, this is the required library that we are going to import. We have import pandas as PD, we have import Cbond as SNS, we have import matplotlib.pyplot as plt, we have import numpy as np, then import warnings.filter warnings. So we can also run our code with shift enter, or we run it here. So let's run it here and see what we have. Good. Our code are okay. So let's call in for B, data collection. Let's call our data set by putting pd dot read underscore csv bracket close and call our data retail sales retail sales data set csv, let's call it. Then we store into a variable called df. It's not correct. Let me look for the tab. Okay, retail data set csv. Okay, that's the right data set that we are going to call. So let's run it and see what we have here. Good. So let's see the first 5 lines of our data set. df.head. Let's run it. This is the first 5 lines of our data set. And let's see the bottom of our data set with df.head. Tail, df.tail. The last 5 data set button is that this last data set button of our data set. You can see this is the first 5 lines, and this is the last 5 lines of our data set. You can see. So let's go to C, that's data processing. So let's call up the columns that we have in our data set. Let's first do that. df.column columns and see all the columns that we have in our data set. This is not correct. We have here columns. Let's read it. This is the column that we have. We've called them out. We have transaction ID, date, customer ID, gender, age, product category, quantity, price per unit, and total amount. However, I would like to have, instead of having this transaction ID and date and customer ID, I want to make it a single sentence, like one. Let me just rename the columns. Let's say df dot rename for the brace. We have columns equals to transaction ID transaction comma, we have next date equals to date comma, we have next customer ID equals to customer customer, comma. We have what next again? We have after customer ID, we have, I think this thing has, let me just run it back and see. I think that went off. No, what happened here? Our DF, I think it's a mistake somewhere here. Column ID I'm looking at, I don't see it again. Something happened here. DF dot columns. Yes, so something happened here. Let me delete this one off. So as we are again, let's continue. We have date, customer ID to customer, then gender equals to gender, then age, comma, age equals to age, then product category product category equals to product. Then what next again? Quantity is equal to quantity, comma, quantity equals to quantity, then followed by price per unit, price per unit, no, small letter, per unit equals to price, then total amount equals to amount. We have total amount equals to total amount. So I think total amount, no, shows amount, comma. So to make it permanent, we said in place equals to true. So let's check again and see our code. We said we want to rename the column, so now we transfer the transaction into transaction alone. Then date will remain the way it is. There's customer ID will be customer. Then gender will be gender the same. Age will be also age. Then product category will be product alone. Then the quantity also will be quantity on its own too. Then the price per unit will also be price only. That's where we are doing. And total amount will also be amount. That's what we do it. So let's run it and see what we have. Let's run this. Good. So let's see what we rename, the data frame that we rename. Let's call it df and run it. So you can see now. You can see we have transaction only. We have date, we have customer, gender, age. This is all okay. Let's just put the df. Let's just put it as the head so that we put it just first in 5 sentences. That will not be normal 5 sentences. That's the head. Let's just put it this way. So you can see the five rows. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5 rows. First 5 rows of our data set. So Let's continue. So let's find the shape of our data set. Let's say df dot shape. Let's run it. We have 1000 rows and 9 columns. These are 9 columns that we have. We have transaction, date, customer, gender, age, product quantity, price, amount. So let's find out if it contains missing value by saying df dot is known dot sum close. Let's find out. So our data is okay. We don't have any unwanted null value. So our data is clean. But to continue, let us check if it's any to confirm if we have any drop. If let's confirm our data is okay, as you can see. So now let's see if there's any duplicate, if we have, if at all. By that we don't have any duplicate. But let's say df dot duplicate if any dot any bracket close. Let's run it. No, there's a message. Data frame object has no attribute to duplicate. Okay, duplicated. Don't duplicate. Duplicated. So we have to correct it. Good, it's false. So we are good to go. So now let's drop. Now that we are through now, let's drop column that we need for our machine learning, because we are going to our machine learning model now. Let's check the one that we are going to drop. We are going to drop, I think, transaction ID and date. These are the items we are going to drop from this table. So let's drop them. We have df dot drop columns, colibris, colibris. We have columns equals to column is equals to transaction ID. We don't have any, no. We have transaction now, so it's transaction that we're going to drop. So now we also want to do date. We have date, then put it. No. I think we did a wrong something there. We have date in place equals to true. So let's drop. We are going to drop transaction and date. I think column 2. I think we do the drop column customer 2. We have to drop customer. We don't want customer. Is that spelling correct? Customer. Okay. So let's run this now and see what we have. Let's run it. So let's see the df.head. Let's see what we have. So good. So what we have left now is gender, age, product, quantity, price, and amount. However, since we dropped transaction date and customer from our earlier data frame, and we now have a new data frame called gender, age, product, quantity, price, and amount. Let's find the data type information of our data set. We said info. We have the dot info. Info bracket close. Let's run it and see what we have. So our data type info is gender column with object while age is int 64, product is object, quantity is int 64, price is int 64, amount is int 64. We have gender and product as a category value. In any data set, anywhere you see a object is category value. So let's just convert our category value into numerical value, because in machine learning cannot convert category value except we convert it to numerical value. And to do that, we either use this commonly method: one, replace method; two, one hex encoder method; and three, map function method. However, whenever we have more than three category value in a column, we use pandas dummies. So let's find the unique value for this category first before we start using the map functions. So let's find the unique value first. Unique value for gender is, we have gender. We want to find out the unique values in the gender column. So let's say gender dot unique bracket close, no, bracket close. Let's run it. On the gender column, we have male, female. So on the gender column, we have the unique value that we have is male and female. So let's assign 0 to male and 1 to female. Let's go. We said the F gender equals to the F gender dot map, because we are using map function here. Curly brace, we have male equals to 0, we assign 0 to male. Then female, we assign 1 to female. So let's run it and see. Let's check the map. Okay, gender, df gender. Let's run it and see what we have. So now let's see the first 5 column of our new data frame. df dot head bracket close. We can see we've converted the gender column to numerical value. You can see 0, 1, 0, 1, 0, 0, 0. So let's do the same what we did here to product, because the second category value is product. So let's do the same. So we have to say, okay, let's do the same. Let's copy these ones and change the unique column. Let's check the unique column. Let's copy these functions here and put it here. Our unique column is product. You can see it's product beauty. So we say product. So let's copy the other one too. Let's find out. Let's copy the other one here. Then let's find the unique. Let's find a unique product in our product column. Let's do that again. Our unique column has the unique of beauty, clothes, electronics. So now, let's assign 1 to beauty, 2 to clothing, and 3 to electronics. Let's do it. So here we change this one to what? To beauty. which is 1, and this one to clothing, which is 2, comma. Less for electronics, electronics X. Let's assign 3 to that. So let's change the F to product, because product column we are looking for now. Unique value product. So let's see, maybe we've done right thing here. See, let's run this one out too. So let's see the first 5 rows of our data set. The F dot head. Let's run it. Good. We can see that we have converted our category value into numerical value. We have on gender and on product. Now we have everything's on numbers now. So what goes? Let's find the descriptions. Let's find the statistic distribution of all this particular data frame. Let's find it. Let's put df. Want to find the statistic of a data frame. Df dot statistics. Describe. Let's run it. As you can see, these are the statistics of our new data frame, of all the columns that we have that we're going to use for this machine learning practical. So let's check if data contains outliers or not. In outliers are generally dependent. Let's find out. Okay, we have description, we have gender. As you can see, our target feature, which is price, has any outlier in the given data set, and if they do, we try to remove it before we start to build our model. However, outliers are generally data points that behave differently from all data points and can be removed by this commonly used method, either z-score method, interquartile range method, which is IQR method, standard deviation method, and percentile method. And this can be known through box plot graph. So let us plot our box plot graph to know if our price y, which is our target features, has any outlier. So let's bring our code to check. Let's say S and S dot box plot bracket close, df to our data frame, square bracket, square bracket, price, which is our target feature, price. Let's run it. It will. Yes, this is our box plot, and this will show us if our target price has any outlier. But as you can see, there's no outlier in our data set. So therefore, let's do a exploratory data analysis of all the columns that we have, so that we'll see the relationship between the price, which is target price, against the other columns. So let's do exploratory data analysis here. Let's say exploratory data analysis, which is EDA. So let's do. We are going to use a joint plot graph for this explanation. So let's use our CNS as well to SNS dot joint plot bracket close data is equals to the f comma x equals to amount against our target future price, that is target future, which is price, y equals to price. No? So let's run it and see. Well, no, I think there's a error somewhere. Our y is equals to what? Our y. Okay, let's see what happened here. You can see could not interpret value price for parameter. Okay, I think we use a small letter here. So Python is very sensitive to all this capital letter or small letter. So let's rerun it and see what will happen here. You can see. So this is the graph, as you can see, between the amount and y. So let's see the other features as well too. Let's see the other features and see. We have what? We have age. Let's copy the formula I just changed out to make it fast. I don't want us to spend too much hour on this particular project we are doing. So let's put this as age. So let's copy this as product. Let's copy this as quantity. So let's run it and see the rest. Let's run this. You can see this is for age. Price are targeted as x hours independent variables, and y is our target variables. So let's see this as to the product. You can see the product graph as you can see. So let's see the joint plot bar of the quantity. Quantity is not correct where I spell it. Let me correct it. Quantity. So let's see it. As you can see, these are the graph between price, which are our target futures, and quantity of our input futures, part of our input futures. So these are the graph that you can see. You can see it here. You can see it is the product. Where is the product? This is the quantity. This is the product. You can see product. You can see the product, and this is the age. This is the product itself. You can remember that our product we categorically into numerical. We use 0, 1, this is 1 and 2 and 3. You can see the ranges. You can see how the price and between the ranges from 0 and also from 1. So you can also see the amount. So because of time, I would have to let's go to the next one by dividing the data set into input features and target features. Meanwhile, in feature scaling, however, feature scaling are divided into two, namely normalization and standard deviation, which also known as z-score. And normalization are also known as mean mass scalar, while standardization or z-score are also known as mean standard scalar. So let's quickly do let's make use of our sklan preprocessing to know, because we want our features. Let's quickly do that. That is from sklan. Let's divide our data set first. Let's divide our data set. So let's divide our data set into input feature and target variables. Divide data set into input features and target variables. Meanwhile, we are going to divide our data set into input feature and target variables by storing our input feature into variable x, which is equals to df dot drop the target variable, bracket close, square bracket, target variable which is price, from our data set, that is price column equals to. So let's run, however, let's give some cell. Let's run this. So let's see the first 5 rows of our data frame for our input features. Dot head. Let's run it. This is our data frame for our x input features. X represents as independent variable. Y, which is the price, represents dependent variable. So let's look for y, which is our target variable. Y equals to the f square bracket price. Normally, in machine learning, we always make sure that our x, which our input feature, comes in data frame. But for the dependent variable, which is y, we make sure it comes on series so that it will make it more easier for us to go further into our practical exercise for this project. So let's look for y. Y is equals to square bracket price. So let's run this and see what we have for our target variables, which is dependent variables. You can see this is for y. This is our target price, our target column, which is on target variables, which is a price. Look at the series. This is the first 5 rows of the series of a price, which is our target variables. So let's import our standard scalar. But before then, as we said earlier, feature scaling are into two types. One, normalization and standardization. Normalization are also known as mean mass scalar, while standard deviation, we also know as z-score, are also known as mean standard scalar. However, on this machine learning model, we are going to use standard scalar because we want every column of our model data set to contribute equally in our input features of x as our independent variables. And the reason why we are using this feature scaling standard deviation method is to reduce our global mean score error to minimize. So let's import our sklearn from scikit-learn. Let's import our sklearn from sklearn, import standard scalar, sklearn preprocessing, sklearn preprocessing, import standard scalar, scalar equals to standard scalar, standard stand standard scalar bracket close our x, which is input features, square bracket, equals to scalar dot fit dot transform bracket close of x input feature. So we are importing for our future scaling that we are using star scalar. So we have to import it from sklan, which is from sklan preprocessing import a standard scalar. Our scalar, we store our standard scalar into scalar, and our x input, which we are looking for, in order to make every input of each column to contribute equally for our machine learning, the into scalar.fit.transform. So let's run it. Let's run it. Good. Let's see the first 5 rows of our input features after we have scaled them. X dot head. Let's run it again. This is our first 5 rows of our input features, and let's see the statistic distribution for input features. Let's see x dot describe. Let's see statistic distribution. As you can see, this is the statistic distribution of our input features. You can see, as you can see that our means and standard deviation, our mean is less than 0, while standard deviation is 1. That's the principle of standard scalar. So before we go into our training test split, normally we believe that in training test split there are 3 methods. We have ordered method, stratification method, and K-fold cross validation method. So these are the methods that we have of training test split method. So but on this particular project, we are making use of order method, which is, let's import our model for a training test split. Let's say our S train. Let's say train test split the method. By importing our train test method from sklan. So let's import our train test method from sklan dot model selection dot model selection dot sklan import model selection import train test split import train test split. Then from there we now say our x equals to into our model building by splitting our data into train test split. Split our data set into train test split by importing from sklan from sklan dot model selection sklan dot model selection import train test plate train test split our S train comma our S test comma our Y train that is dependable our Y test equals to train test plate comma bracket close our input features our dependable variables test size equals to 0.2 our random state equals to 42. However, the meaning our import our sklan from sklan model selection import train test split our input our S train test S train test Y train and Y test equals to train test split equals to our input variables and our dependable variable which is price which represented by Y and test size we are using is 0.2 which is 20% and random state equals 42. The meaning of this random size 22 means that the test size are divided into two. 80% of that data are used to train the dataset and 20% of the dataset are used to test the training dataset with the validation model. Why the random state 42 means that we are using equal row numbers in the given data, particularly the dataset frame we are using to test the dataset on our model. So let's run our dataset now before we go into the shape of our model. Let's run it. As you can see, so let's find the data shape of our model. Let's give a note here. Building our model, building our model data shape, our model data shape equals to s underscore train dot shape comma x test under x test dot shape. So let's run it. Oops, the mistake somewhere here. S train dot shape. No, I think here was a mistake. Comma, I put comma here. It's supposed to be dot. So let's run it again. You can see we are using for our training data set, we are using 800 rows, 5 columns. While our S data sheet, we are using 200 rows and 5 columns. So let's build our model by using our linear regression. That is building our model, building our model with linear regression by importing our linear regression model our model with linear regression. Build our model with linear regression, regression, linear linear regression by importing from sklearn, by importing from sklearn dot linear dot linear regression model model from sklearn linear regression linear model import linear regression and model equals to linear regression bracket close model dot fit bracket close our independent variables x input training comma y training so let's say from sklearn supposed to be small letter sklearn linear model import linear regression model is equal to linear regression good model dot fit our string so let's run it and see. Oh, there's a mistake somewhere here. The model named sklearn linear model linear sklearn dots linear model import linear model sklearn linear the mistake somewhere here from sklearn dot let's correct it okay from sklearn from sklearn linear model good then now said import linear regression so let's run it again and see good our model works now so let's spread it. These are our original predict test. Let's spread it spread equals to model dot predict bracket close our s test so let's run it so let's give our y test is equals to y test 5 columns 5 columns let's run it can see this is our original project text for our model predict test. We then compare our model predict value from the original value by pred 5. So let's write it down. Let's write it down. So so let us check for the model predict test. We then compare our model predict value from the original what from original value predict value from original value from original value from the original value. So pred square bracket pred square bracket fm 5. Let's run it. You can see this. We have to compare now. Here from our original value we have 500, but said our predict value we have 496, followed by the second one 50, followed by 88. Then the second was 300, we have 214, and the last one, the last was minus 25, and the last one 500 we have 602. So let us evaluate our model to see how global minimal error we have, to know maybe our prediction is correct to the global minimum in error. So let us evaluate. Let's evaluate. Let us evaluate our model. However, there are multiple methods to evaluate model in linear regression, and the three popular ones are mean square error. So let's evaluate our model. However, there are multiple methods to evaluate model in linear regression, and we are going to make use of the three most popular ones, which is mean absolute error, mean squared error, and root mean squared error. However, let's import our mean squared error from mescaline. Dot matrix import a mean square error mean square error, comma, our mean absolute error, mean square absolute error, so let's run it. Good. So let's format our mean square error. Print bracket close curly brace First format our have mean square error mean square error then bracket close our white text and spread. Let us check again. From sklearn dot metrics import our mean square error, means absolute error, then we print our f format mean square error, mean squared error, y underscore test and our predict. So let's run it. That's our mean square error for our predictions on machine learning practical exercise. Let's check for our mean absolute error as well. Let's copy this particular method and paste it and change it to mean absolute error. Change this one to mean absolute error. Then we say our white text the same the way we did the first one. So we change this one to absolute, absolute, absolute. Since it's absolute, we are looking for absolute, absolute. So absolute error and white text. Let's run this ones at 2 Let's see what we give us. You can see 56.4. The mean square error gives us 55339. So let's check for our. So let's copy our F format for mean absolute error and paste it on the other line so that for us to find the root mean square error. Copy this or paste it in the next line. Then we change this to root mean square error. Root mean square error. Then we format it with numpy. We have numpy dot bracket. Then we close it here so that it is a run. So let's run this and see what we have here. Good. We have 7.5 that we have here. So let us now look at the best options of doing the lasso regularization to be sure and confirm the lowest means of this. So let's go. I think there's a mistake somewhere here. It's not mean absolute, it's mean square. There's a mistake here. We don't mean the mean square error. Square error. Mean square error. So let's run it. Yes, that was also our here, 74.2.42. So let's go to regularization, last regularization and regression. We then try the two type regularization, that is lasso and regularization. By lasso regularization or regression, we are going to visit the lasso regularization official document of scikit-learn to check for the parameter from sklan. So let's go to sklan and copy the default model from sklan. Let's copy this. We copy this and we paste this on the inside our project. Copy paste. Then before then, let's do a markdown, that is lasso regularization. By then, from sklan regularization, from sklan linear, from sklan, no, not covariance. We are not using covariance. We are using dot linear model import lasso. Then here we correct it. Equals to lasso alpha. So let's break this. We break this so that we'll be able to see other parameters. Let's break it from here. We break it from here. So we have to delete this, the multiplication sign. Then we now say our ladder dot fit. We said lasso underscore model dot fit our S string and Y train. Brackets. So, however, we are performing regularization to check the techniques that gives minimum value of root mean square error. The one that gives us minimum value will be our best model. So let's run this first. Fine. So let's run our predict. Let's fit our lasso model regularization on training our model set. So let's predict our lasso model predict by saying lasso underscore pred equals to lasso underscore model dot predict bracket close s test and run it. No, this is not correct. So let's run it. Let's run this. Good. So now let's copy our root mean square error and change the predict it to lasso underscore predict. Let's copy, then we paste it here. Then we now say lasso underscore. We change this one, lasso underscore. Let's see what we give us. Let's run it. It will give us 74.50. So let's try which is regularization. Regularization. By visit our sklan documentation to check for the parameter. This is our sklan and this is our parameter for regular, you can see. So we just have to copy all this. We copy this like this and go to our home page and paste it here. Then we break it just the way that we did this first one that we did for the lasso regularization. We have to break it. We go there, we break it from here so that you're able to understand it. Then we change the one for lasso to reg to make it more easier from sklan. Let's say from sklan sklan dot linear model dot linear sklan linear model import reg. Then we will say here say model underscore reg equals to reg. Then we cancel this just like the way we did for the lasso. That what we do here. Then we copy this, paste it, and we said this will be reg, not lasso again. Reg. You have to change it. Then we look at it once and for all. Then we run it. You can see we run our model. So let's predict our s just as we did the last time. Our s text. Copy this, paste it, change it to reg. And run our text as usual. Then we copy our root mean square error and change the last second to the last phrase, which is lasso to reg. And run it. You can see it still have the same 74.5. Likewise, this as well. We almost have the same regularization on this. So that means our mean square error that we have said here that to perform a regularization is to check the techniques that give minimum value of root mean square error. The one that give us minimum value will be the one that will best our model. So what was the best minimum value? So after doing the regularization, we discovered that this is the best mean square error that we have. That is 74. That is smallest, closer to our model. So that's how we can go as far as this our machine learning linear regression in Python for beginners practical. Thank you for this. Target future.